Hello there and welcome to another Pars for Physics A-Level tutorial. Today we'll be finding the point of zero net gravity on a particle in a gravitational field. And today we'll be using the quadratic equation. Instead of what they normally use, you may have seen this. This is the square root of mass 1 divided by mass 2 equals r squared over r squared. And that is a standard equation for large masses, so reference the Earth and the Moon for argument's sake. So they would ask, where would there be zero or no net gravitational force between the Earth and the Moon? And they would use that equation. But today we're going to be using the quadratic equation for a change. And the question is, two rocks are floating in the vacuum of space. One rock has a mass of 6 kilograms, while the other has a mass of 1 kilogram. If the distance between them equals 10 meters, at what distance from the larger mass would the particle need to be placed so that it experiences no net gravitational force? So the key there is to read the question, and it does say at what distance from the larger mass would the particle need to be placed. So bear that in mind when we try to solve this. So here's our scenario. We have our mass 1 there of 6 kilograms and a mass 2. We have our little particle there, and that's placed randomly for this example, but what we need to know is at what point from the large mass do we need to place that in order for that particle to equal 0. So the first thing we must do is pull up the standard universal gravitational equation, which we should all know by now, which is the force is equal to big G times m1 times m2 divided by r squared. But we're going to try and derive a quadratic formula where we have two variables and we need to set them equal to each other and make sure they're equal to 0, because that is what we need to find, the point where those two masses equal out to 0, and that will give us our distance. So we have to take each mass individually and give it its own equation. So the first one for mass 1 would be the force equals big G times m1 times little m, and little m is that particle. It's negligible, it's massless for this argument, divided by a distance x squared, which this is what we've got to find. Again, for the second one, this is F equals big G times the mass 2 times little m, and this is divided by 10 minus x, and that is squared. So obviously, as in the question, it wants to know the distance between here and here of the larger mass, so that is x squared, and for the little one we know that that is 10 meters away from m1 minus that unknown x, so that's where we get the 10 minus x from. Okay, now what we need to do is make them equal to each other. So there we go, one is equal to the other. We can then see now that through algebra that some of those things cancel out. So the g's cancel and the little m's cancel. So as you can see, the little m and the g are totally irrelevant in finding this distance. The next thing we do is to put them like that. So that's what we now have. m1 over x squared equals m2 divided by 10 minus x squared. Now we cross multiply, which gives us m1 times 10 minus x in brackets squared equals m2 times x squared. If we expand 10 minus x squared, that's what we end up with. I'm taking it through as many steps as I can to help you with the math. Now we put the masses in, so we now have the 6 and the 1. So we end up with 6 times 100 minus 20x plus x squared equals 1 times x squared. We can now times that out, and we get 600 minus 120x plus 6x squared equals 1x squared. Now we've got to think about how we're going to rearrange this to derive our quadratic formula. So we need to start thinking of a 0 at the end there, so I'm going to subtract 1x squared from each side, and that gives us the 600 minus 120x plus 6x squared minus 1x squared equals 0. So now all we have to do is collect like terms and rearrange it into our quadratic formula, and there we have it. So 5x squared minus 120x plus 600 equals 0. So our quadratic formula, this would be A, this would be B, and this will be C. So for those that have forgotten the quadratic formula, here it is. For those that do not understand that, I advise you look up quadratic formulas and equations. So if we plug in our equation into that, we end up with two answers, like always with a quadratic, and the answers will be x equals 7.1 or 16.9. Well, obviously our answer will be x equals 7.1, as we only have a distance of 10 meters, so 16.9 meters is technically another place where there is no net gravity, but we only want the distance between the 10 meters. So now we have x, this distance here, equals 7.1 meters. So if we place this particle here 7.1 meters away from this mass here, we end up with our answer. Well, I hope that's helped you, and I hope to see you very soon for another A-level physics tutorial.